Welcome. I'm Margaret Palmer from the University of Maryland. Work on stream and river restoration and also direct the National Socio-Environmental Synthesis Center, which is an NSF center. I'm really happy to be facilitating the dialogue on harmful algal blooms. It's a huge issue. If you look at recent NOAA reports, they indicate about 65% of coastal waters and estuaries suffer from excessive nutrients. And there's a lot of consequences from that. We know that we can have serious periods of hypoxia in these bodies of water. We can see losses of iconic species, as well as biodiversity decline, degradation in terms of the recreational qualities, habitats. Inland waters suffer, of course, in some ways even worse, but the problems extend well beyond nutrients to a variety of other things. But one of the associated problems that has come with eutrophication is the problem of harmful algal blooms. We've been hearing a lot of this in the news in the last few years because of some very serious problems, particularly in Florida, but in other areas as well. There's a lot of unresolved questions around this issue, and we're going to hear from two people today that are going to provide a really good introduction and overview of where we are. Some of the categories of issues that remain really today are working towards better abilities to predict when these may occur, under what conditions, whether or not there are threshold conditions that we can anticipate, how this might be influenced by climate change. The efforts that have gone into recovery, even when we see nutrients reduced dramatically in these systems, recovery, for example, of biodiversity, but also whether or not algal blooms occur, is only modest. And so what's going on when the trajectory to decline is really different from the recovery process. We see this hysteresis, what's behind all that. So predicting, understanding how to recover waters and prevent this. And then, of course, there's major issues associated with potential health impacts and costs. And so with that as background, we have two speakers. I'm pleased to be able to introduce them. Ellen Galinsky is going to talk to us first. She's president of Ellen Galinsky LLC, but she's been a major player in the Office of Water for EPA, particularly associated with this specific issue. Prior to that, she was with the Virginia Department of Environmental Quality, the Water Division Director, so she's got tremendous experience in this arena. We've asked her to give a retrospective, and that's going to be 10 to 12 minutes or so, and that'll be followed by a talk by Tim Davis, and I will introduce him at the appropriate time. So, Ellen, welcome.
Check these arrows here. Well, thanks so much, and I'm delighted to be here and to see so many old friends in the audience and colleagues, many of whom I worked with recently. So what I want to do is sort of set up for you how the WSTB is important in moving forward water quality science and policy, and in particular to set it up for what might be a role for the WSTB in helping with harmful algal blooms. So why the WSTB? Why are we, of course, probably preaching to the choir, because all of you are familiar with the work of this body. But the WSTB is unique because it represents a partnership between a lot of different stakeholders, not just academics and government, but consultants, other stakeholders, users. And it really is an independent consensus science body that can help inform policy and decision-making, not just at the federal government, but many of the products which you saw represented in that notebook we got when we came in are used by local governments, by various stakeholder groups as an independent assessment of the state of the art, the state of the science. I don't think I have to tell those of you in this room that the role of bodies like the WSTB are even more important now when the use of science and policy making is being discounted very openly. But yet there are many people down below that upper level of politicians who really want to know what the science is and want to know, want to use it as they work on regulations and policy and water. So can't emphasize that enough. So what I'm going to do is give you some examples of work, recent work that the WSTB has done on water quality issues that I'm personally familiar with from my time at EPA, and then maybe suggest how this could help in the Haves arena. So I want to start off with, certainly at EPA we call it the Stormwater Bible, probably called that in other places too, but a 2009 study on urban stormwater management. And this study was commissioned by EPA to review its own program, its own stormwater program, and suggest how that program could be improved, given the fact that the regulatory issues surrounding stormwater are limited by the Clean Water Act. So the report, which it's not just a report, it's a book this thick. And I was going to bring it, but it was too heavy, bring on the train. But the report summarizes the sources of stormwater, the consequences of stormwater on water quality, and also gives suggestions for management options. And that book is still useful today. EPA used the report to make improvements in its stormwater program. We also used it as we tried to issue a more comprehensive stormwater regulation that never did get out of the gate, unfortunately. But a lot of the things that we worked on in that draft regulation we're implementing more on a voluntary basis. So really helpful study. I'm sure that took a long time to put together. Something I'm very familiar about is work in the Mississippi River. I was lucky enough to be the co-chair of the Gulf of Mexico Mississippi River Hypoxia Task Force for several years, which is a state federal task force looking at what we can do about the Mississippi River. So I found this is really interesting because here's a study that was commissioned by a nonprofit organization. So it was not a federal agency that commissioned the study. I know a lot of the studies are often groups of partners, but in this case, I don't believe EPA was a money partner on this, but the recommendation sure applied to EPA and other federal agencies. So the Ignite Foundation, very active in Midwest water quality issues. So this book, again, very helpful in summarizing what's going on in the Mississippi River with regard to water quality, where's the pollution, water pollution, focusing on nutrients really, where's it coming from, what are the consequences, what are the appropriate roles for state and federal agencies in addressing this nutrient pollution. A couple of things the report called for, and I put asterisks by areas that actually have been addressed by the federal and state agencies involved in the Mississippi River to show that these recommendations do get listened to. Called for a coordinated water quality monitoring and assessment program and a shared database, and that's being worked on today as we speak. It started a while ago, but trying to get all the states and the federal agencies on the same page to share data and have one data portal for information on the Mississippi River. It's not as easy as it sounds, or maybe it doesn't even sound easy, but it's, you can only imagine. State, federal, and then also bringing in other data like that the Nature Conservancy collects and things like that. So, but it is being worked on, and it's really necessary. The report did ask for development of a basin-wide TMDL. You'll note there's no asterisk after that because such a TMDL hasn't been developed. As complicated as the Chesapeake Bay TMDL is, think about it up and down the Mississippi. 12 main stem states, more states beyond that, it would fall under its own weight. Instead, there was a request also to use not just Clean Water Act tools, but non-Clean Water Act tools for voluntary reductions, make them a little less voluntary for non-point sources, agriculture in particular, to make progress. And again, that recommendation was taken to heart and really formed the basis of the state nutrient reduction strategies that each of the 12 main stem states has. They're scientific based. The land-grant universities worked on them. Kathy, I think you worked some on that with Iowa State. And they're now being implemented. And it also highlighted the need for better state and federal leadership led by EPA. And that really helped energize the Hypoxia Task Force that I co-chaired. And really in the last few years, that task force has really become meaty and, you know, is responsible for actions to decrease nutrients. So that report was actually followed by a report that EPA commissioned because there were so many recommendations in the first report, and that's Nutrient Pollution in the Mississippi River 2009. EPA wanted advice on further development of nutrient reduction programs and documentation of the effectiveness of the strategies. The report called for an EPA USDA nutrient control implementation initiative, and that actually did get underway during my tenure at EPA. We worked closely with USDA for the WQI, I forget all the initials, the WQIF, Water Quality Improvement Initiative, WQIA, excuse me, and in it, we also followed the next suggestion, which suggested identifying priority sub-watersheds for initial actions and development of nutrient load reduction targets. So with the money from USDA NRCS, each state identified at first 3 priority watersheds where they wanted to take action and use both USDA and EPA funds, and then USDA actually worked further on targeting further watersheds for that, which, you know, was a great suggestion. And also the task force, with the help of modeling the Sparrow model from USGS, developed a load reduction target of 45%. I think I got that right. Sometimes I can never remember if it's 40 or 45. Of nitrogen and phosphorus in the basin, and that's what each state used to develop their own nutrient reduction plans. And they were free to do further modeling that was more specific, but most of them just adopted that target. That's been really helpful. Then we have an interim progress goal. And the report also asked for an expanded and improved water quality monitoring, and modeling is critical. And work is ongoing on that, but I wouldn't say it's necessarily successful in that it takes money and dollars have been limited. Let me switch gears a little bit and look at this report that didn't necessarily say that EPA did a good job, but really, again, helped move the ball forward. And EPA was involved in helping to develop numeric nutrient criteria for Florida's waters. That was through legal actions. And in the end, we did develop the water quality standards, and they published them, but then this Florida developed their own based using the same science, and we withdrew the federal ones because the states are supposed to set the water quality standards. But as with any regulation at EPA, there was an economic analysis that went along with it. And EPA requested a review of that economic analysis because there were a lot of other stakeholders criticizing that analysis. And, you know, the report did not give EPA a gold star. I'm just going to say that. The report identified several key, while they said the spirit of the review was good and the techniques used, but it identified several key flaws in the analysis really based on the assumptions used. and had suggestions for how to improve that. And these recommendations did lead to some changes in the final analysis. But to me, that's an example where, again, the board, consensus board with an independent view was able to give a good technical review of a product and make suggestions for its improvement. So what about Haves? You're going to hear from Tim about what's going on with the Haves work and why controlling Haves has become a water quality priority, not just at the federal level, but the state and local level, because the impacts are very local on local economies, as well as their water supply. Much work is being done by scientists and managers at all levels. Believe it or not, Congress actually is concerned about harmful algal blooms. They have been for some time. I can't remember the first year of the Hypoxia, 2008 or
98.
98, oh, even before that. But it continues to be reauthorized, has the worst acronym ever, harmful algal bloom, because you have to sort of, to get it out, harmful algal bloom and Hypoxia Research and Control Act. And there actually is a little bit of money behind it too. Directs resources toward interagency study of the issue. And the Hypoxia established an interagency working group, which I was honored to co-chair during my time at EPA with NOAA, and involved many different agencies, not just the usual suspects, but even the Center for Disease Control, since harmful algal blooms can be a serious health issue for pets and humans. I commend to everyone, if you haven't seen it, the February 2016 interagency report. Not going to read that whole thing, but it develops, it's called a research plan and action strategy, but honestly, it's a compilation of what we know about harmful algal blooms, where they occur, how they've been increasing in frequency, what we know about the possible causes, as well as what we don't know, because we don't know what the actual mix is that leads to development of a harmful algal bloom in one place and not another. And then it also has a list of recommended actions that would be helpful to prevent Haves. And a lot of that list contains things we don't know. To me, that's fertile ground for the WSTB to sink their teeth into and look at how this body here can further elucidate that work. So use it as, a lot of times, the Academy starts with that kind of document. That document's already been prepared. It could be used as a jumping off point to really make some progress on this issue. And I think there will be support from federal and state agencies on this issue because it's an environmental and an economic issue. So just to highlight, get a teaser for Tim's talk here, the couple of nasty pictures of harmful algal blooms in the dead zone in the Gulf. So with that, I'll turn it over to Tim.
Thank you, Ellen. While Tim makes his way up here, I'll just mention a couple things about him. He is a well-known expert on harmful algal blooms. He was at the Great Lakes Research Lab in Ann Arbor with NOAA for a good while. He's recently gone to Bowling Green State University, and he has agreed to tell us about the state of the issue currently and really address some of those things I talked about at the very beginning. That is, what are the technological issues that we need to think about? Where are we with respect to predicting, monitoring, assessing, et cetera? Welcome, Tim.
Okay, thank you very much, and thank you for the opportunity to speak to you all today about harmful algal blooms, and thanks to Ellen for that great introduction. My voice is going to try to hold out. I have 20 minutes to go through 47 years of research on harmful algal blooms, and last week my body gave out, and so my voice is still recovering. So if I have to stop or pause, I apologize in advance. So one other thing I'd like to point out is that Bowling Green State University is in Ohio, not Kentucky. Okay, so we exist. Bowling Green, Ohio exists. But in order for this talk, when I was first approached to speak to you about this, they wanted me to give a forward perspective, where we are now, where do we need to go in the future, and how can the Water Science Technology Board assist in that. But I decided that in order to understand where we need to go, we need to really understand where we came from and how we got to where we are now. So I'm going to start with some of the research that was done well before I was born. For reference, this board was founded a year after I was born, so I'll let you do the math. Okay. But where we have come from and where we are going is significant because harmful algal blooms are such an important issue to freshwater and marine coastal waters throughout the United States. So back in the 70s, harmful algal bloom events were really considered regional issues. As you can see from this map, there were a couple of what we call the neurotoxic shellfish poisons, the paralytic shellfish poison Ciguatera, occasional anoxia, but it was really a regional issue. Very few events were well known. And also, we had some issues in the Northeast, the West Coast, the South, but also Lake Erie, which doesn't appear on this map, which is interesting, but I want to circle it anyway because obviously I'm from the Great Lakes and I want to highlight that. There was no national recognition of the problem. Again, it was considered a regional issue. Funding was very difficult. There was no specific funding lines for harmful algal bloom research. We were competing with all other water programs in order to fund this work, so it was very hard to get funding. There was no HAB community. We didn't exist. There were a few researchers looking into this topic, but we did not have a coordinated HAB community, which we do today. So that being said, we had all these really interesting discoveries to be made because harmful algal blooms and the recognition of it was really at its infancy. So I want to bring up Lake Erie because Lake Erie was integral in many of the water laws and agreements we see today, such as the Clean Water Act and the Great Lakes Water Quality Agreement. So back in the 60s and early 70s, well before I was born, Lake Erie was at the forefront of freshwater pollution from point source pollution, right? So we were the butt of jokes. Not that Cleveland needs any more negative press, but it was really the industrial growth in the Cleveland area, in those Great Lakes shipping cities, that drove Lake Erie to be considered a dead lake. So HABs and hypoxia, two of the same issues we see today, were occurring in the 60s and 70s, and that led to the environmental movement. Everyone heard of the Cuyahoga River catching on fire in 1969? Yeah, well, it caught on fire 8 times before that. So that was not the only time, right? That's just the time that we heard. It's the time it made national news. So Lake Erie was really a founding block for the environmental laws and protections we see today regarding water. We were also mentioned in Dr. Seuss's book, The Lorax, right? So in that whole line about the humming fish, the last sentence in there from his original version in 1971 was, "I hear things are just as bad up in Lake Erie." You know it's bad when Dr. Seuss writes about you. But it was also a time where we were making very important scientific discoveries about harmful algal blooms, especially in freshwater systems. So this is David Schindler's work up at the experimental lake area in Canada, in Ontario, Canada. He was able to conduct these whole lake experiments and was able to determine that phosphorus was a primary driver of freshwater harmful algal blooms. That was critical because it was the phosphorus targets in that Great Lakes Water Quality Agreement in 1972 which helped restore Lake Erie. And I'll get into that in a few slides. But this work was integral in founding most of the freshwater harmful algal bloom research up until this point. So this was a very, very important study. But getting into the 1980s, we start to see harmful algal blooms reach the national map. All right, so this is the time of big hair bands and overalls actually being a fashion icon. We also had harmful algal blooms occurring in these coastal regions. So for example, brown tides appear in Long Island and Maryland. Now, as you can see on the very far side of the slide, that's the Atlantic Ocean, and this is Great South Bay, Long Island. That's not turbidity, that's a harmful algal bloom. Okay, it had devastating impacts on the regional economy because it, along with overfishing and some other human drivers, had a big impact on the shellfishing industry that was a staple for Long Island and Maryland's economies. So when we talk about economic impacts, harmful algal blooms have had economic impacts back since the 80s. We had red tides occurring up and down the east coast of the United States, from Maine to Florida, not always the same organism, but these are events that made national headlines. Not the one about the naked man taken for a ride, but if you look at the National Shellfish Alert widens, mussel toxins found, these were the paralytic shellfish poisons. And these toxins, saxitoxins, domoic acid, these toxins were making their way into shellfish, and it was having economic impacts on not just the shellfishing industry, not just the fishermen, but the ripple effects through that. So the seafood restaurants, all the seafood brokers. So you could see the economic impacts of these red tides occurring. And they started again to make national news. Congress started to become very interested. But at the same time that we were having these economic impacts and these coastal marine harmful algal blooms gaining national attention, the Great Lakes were also gaining national attention because the Great Lakes Water Quality Agreement 1972, the phosphorus limits that were set, the point source pollution controls that were put in place were having a positive impact in Lake Erie. So we were actually seeing Lake Erie be transitioned from what considered a dead lake to a model of lake restoration due to point source controls and legislation and binational agreements between the US and Canada to reduce phosphorus loads into those systems. So we were actually, Lake Erie at one point in time was considered a poster child for lake restoration. But we looked at that and we said, great job, we've done it, Lake Erie is restored, and we took our eye off the ball, and I'll get into the ramifications of that in a few more slides. But we even convinced Dr. Seuss. So a couple of Ohio Sea Grant researchers wrote him and said, hey, you're giving us a bad rap in your book. You need to remove that line. He looked at the data and he said, yep, you're right. And so recent published versions of that no longer have that line in them. So we were successful. Great job. However, the Lorax came back. So from the mid-90s to current day, not only have harmful algal blooms and hypoxia come back in Lake Erie, we have seen them, especially harmful algal blooms, increase in intensity and duration and potentially even toxicity. So these issues have come back. So we went from a dead lake to a model of lake restoration to a poster child for harmful algal blooms, not just in the United States, but globally. Okay, so this is an ongoing issue in this region. So that is kind of the history of a brief history, a very brief history of where we are. The current HAB impacts, as you can see, we went from just a few different paralytic shellfish poisons and these shellfish poisons to look at the list of harmful algal bloom, toxin issues, and fish mortalities, just aesthetics, issues with desalination plant disruptions, macroalgal blooms, and freshwater toxins. It has expanded considerably. And when we look at harmful algal blooms now, if we have an updated map, we could see that they are impacting pretty much every coastline we have in the United States. And those little green dots, so these are all the different paralytic shellfish poisons, Carlidinium, which is another type of harmful algal bloom, brown tides. The green dots are the cyanobacteria. And you can see those little dots. That's not just where they occur in that state. That's just saying that that state has problems. If we really wanted to look at the freshwater harmful algal blooms, the map would look like that. Because all 50 states deal with these blooms in multiple systems, from small ponds to the Great Lakes. So this is truly a national issue. But why are they proliferating? Why have they gotten worse? Well, we know that nutrients are a key driver. They're not the only driver, but they are a key driver, especially in freshwater systems. And when I pointed out earlier that phosphorus, those experiments by Dave Schindler, were a driver, recent research has also shown that nitrogen is also extremely important in these freshwater blooms as well as in coastal marine systems. So we have nitrogen versus phosphorus. It's a debate in freshwater, but the consensus to date has been that we need to have dual nutrient control in our freshwater system in order to have blooms that are smaller, less toxic, and don't last as long, so decrease the impacts. Loss of key food web predators. When the brown tides and the red tides moved into some of these systems, especially the brown tides, it had an impact on the ecology. It basically caused a mass die-off of shellfish that are important. They are the filter feeders. They are the cleansers of these systems. So loss of key food web predators allowed these blooms to proliferate even more than they had in the past. Invasive species, especially in the Great Lakes, may have altered ecosystems which give harmful algal bloom species an advantage. Global climate change has and will continue to have an impact not only on harmful algal blooms, but our ability to deal with them. And finally, we're looking harder. We cannot discount the fact that today there are many more researchers being able to study harmful algal blooms than there were in the 60s and 70s. So it's not that they weren't occurring then, it's just that we weren't looking for them. And as Ellen pointed out earlier, this is the Harmful Algal Bloom Hypoxia Research and Control Act. No one has to say that again. But HBARCA, it was initially authorized in 1998, was reauthorized in 2004, 2014, and is currently up for reauthorization 2 years early. So it was not due for reauthorization in 2018. It's being reauthorized. It made its way, I believe, through the House and is currently sitting in the Senate. So this shows how much of an attention Congress has on this issue. And this legislation, as Ellen said, brought money with it. And that money was critical, especially in the early years, to these programs which were specifically focused on harmful algal bloom research. Mainly, initially, it was funded NOAA, NSF, EPA. It has since been reduced mainly to being administered by NOAA. But this is the EcoHab, Ecology and Oceanography, the MERHab, PCMHab. Those three programs were critical in driving the understanding, the technology, and the products we have for harmful algal blooms today. The Centers for Ocean and Human Health, also extremely important. So the current status of HABs research in the US is that we've been a highly productive field. We have made many advances and many products that have had important impacts over the past few years. We've greatly improved the knowledge of regional HAB phenomena through these programs, so the EcoHab and MERHab programs. These programs have allowed multiple interdisciplinary projects to be conducted, which is so critical in this work. And finally, the marine and freshwater communities are much better integrated. We have a National Harmful Algal Bloom Committee. We have our biannual meetings that bring marine freshwater folks together because we know that these toxins, especially the freshwater toxins, can cross the marine freshwater continuum. And finally, our research community is considered both nationally and internationally. It's highly regarded. We are looked at as a leader in this field, and we cannot lose that. So some of the products that have come from this, I don't have time to get through them all, but some of the regional products which have been critical for protecting human health and economies in some of these regions. So the Northeast USC, especially in the Gulf of Maine, these Alexandrian blooms, which produce paralytic shellfish poisons. We have the Northeast PSP. That is the research that has allowed for this to occur was done through the HBARCA legislation and the funding that came through that. Also, advanced technologies, early warning and detection has allowed for technologies that can monitor even when we are not in the field, because that's one of the big issues is getting out to some of these blooms is very difficult because it requires fairly large ships just to be safe. In the Southeast USA and the Gulf of Florida, this is one of the operational forecasting systems through NOAA for the red tides, for the Carlidinium tide, or not the Carlidinium, excuse me, the Karenia brevis tides and the brevetoxins. This is an operational forecasting system. And as you can see, these systems that are produced have always been a strong collaboration between government, private industry, and academia. That has been critical in this research. Also, again, advanced technologies, early warning detection systems, and this is going to be a theme that I'm going to go through. In the Northwest, again, advanced technologies allow to monitor these pseudonychia blooms which produce domoic acid, and domoic acid is an amnesic shellfish poison. The research and the collaborations that have been funded through Hypoxia and through these programs have allowed us to develop those early warning and these sites that managers rely on to understand where a bloom is, where it may be toxic, and where it may be going. And finally, in the inland coastal and Great Lakes, this is just one example in Lake Erie. The Lake Erie harmful algal bloom forecast was just this past year moved into operation. So we project the size of the bloom, we predict it, we monitor both federal, state, and academics all monitor this bloom, as well as internationally. This is one example that highlights the importance of international collaboration. The US and Canada both work together. I work with many Canadian counterparts in order to monitor Lake Erie. We also have other advanced technologies. So this, under number 4 forecast on the right-hand side, that is the HAB tracker, which is a near-time for 5-day forecast of where the bloom is going. And then we disseminate this data so that managers have it because that's what they need. Now, while we can currently monitor and predict the movement of the bloom, we cannot predict toxicity, and that's critical for drinking water safety. So what are some of the negatives? Where are we at right now? Well, these events are starting to become and continue to become more frequent, larger, and potentially more toxic, and that could have further impact on local economies and human health. So as everyone probably is aware of the Toledo water crisis. I'm obligated to mention it because I'm from the Great Lakes region, but that was one event that got national and international attention. The Lake Okeechobee State of Emergency in 2016 also gained national and international recognition, and the Utah Lake algal bloom. So these are freshwater. On the marine side, we have yearly closures in the Northeast USA from Maine all the way down to New York of shellfish beds. Huge economic ramifications for the communities that rely on that for their income. We had the first detection of pseudonichia and domoic acid on the East Coast, again, shutting down shellfishing industries. On the West Coast, we had one of the largest blooms that we've ever seen. It stretched from the Gulf of Alaska all the way down to Mexico, and that was pseudonichia domoic acid, and that had a massive impact on the Dungeness crab fishery in that region, a $65 million a year industry devastated by that bloom. And of course, the red tide blooms on the Gulf side, this is the Carenia blooms. This has had major economic impacts to the regions where they hit, because these toxins can become aerosolized, make their way onto beaches, causing asthmatic symptoms. So people have had to sell their houses, decrease tourism, all the ramifications that come when you can't use the beaches, and no one goes to Florida except to use the beaches or to retire. All right, so if you can't retire on the beaches, fewer people are going to go to Florida. But what are some other negatives too? Is that while harmful algal blooms have been increasing in severity and increasing in prevalence, are decreasing our funding has decreased, and this may have caused us to lost a generation of HAB scientists. And could we lose another? So when we look at funding, and this is through the NOAA C-score, which manages the EcoHab, MERHab, PCMHab, funding has decreased. The number of projects have also decreased to a point where from 2012 to 2015, they weren't able to fund any projects. And this is one of our main lines of funding. However, again, harmful algal blooms have bipartisan support in Congress. This was a letter written to then President-elect Donald Trump, and it was signed by 47 members of the House, Republican and Democrat, stating that harmful algal blooms are an issue and that continued funding needs to be continued in order to solve these problems. This was a letter that was just sent to Mick Mulvaney last week, or 2 weeks ago, excuse me. Again, signed by 53 lawmakers, saying that harmful algal bloom funding needs to be maintained in the federal budget because it is critical. If we lose the funding, we lose the research, we lose the ability to improve our forecasting products and improve our ability to monitor and address this national issue. And I always joke around that if we ever solve harmful algal blooms, we also solve bipartisanship, because it's one of the few things that I've seen bipartisanship on, especially in this political time where you have 53 lawmakers, about a third Republican and 2/3 Democrats signing this letter. So where do we go from here? Where can the Water Science Technology Board help out on this? Well, one, again, this is a plug. I'm a researcher. We're going to whine about funding, but we need these programs. They're critical. We need that funding in order to maintain and improve these systems. But one of the big issues that is a knowledge gap is the socioeconomic impacts of Haves throughout the U.S. And this is an area where I think the Water Science Technology Board could really make a difference, because what are the economic benefits of improving water quality, right? We know that there are ramifications for continued decrease in water quality, but what are the economic benefits for improving water quality? There have been some regional studies done, but never a national study, never a synthesis of that information. What is the social science surrounding changes in water quality? So not just from an economy, or not just from economics, but social science. What happens to communities when they are continuously impacted by these blooms? Do we see crime increase? Do we see domestic violence increase? Do we see stress in the home increase? These are questions that we just don't know the answers to, but that could be very important when we look at the impacts of harmful algal blooms on economies and on society. We need to continue to invest in advanced technologies. Just as Dave was talking about with reuse in water, these technologies to provide early warning or advanced warning of harmful algal blooms are critical so that we can protect human health until this issue is solved. And we know it's a watershed issue that ends up in the lakes, but we need to understand what's going on in the lakes, and we need early warning and prediction of these toxins and of these blooms. And finally, climate change, especially for freshwater harmful algal blooms. There have been multiple studies that have shown warmer temperatures, more rainfall leading to more nutrient input, higher nutrient loads because of that rainfall, all will lead to larger blooms that are potentially more toxic and last longer in duration. And with that, I'll just end by saying, because that's so critical, we've actually seen a drop this year by about 50% or about 40% in grants that have climate change in the title. But we're switching to extreme weather events or environmental change in order to combat that. Yeah, but we need to know climate change is going to impact our ability to meet domestic action plan targets. It's going to impact our ability to reduce nutrient loads, because currently where we are and the percent reductions we need, or at least we think we need for certain systems, will be impacted by climate change. If we ignore it or if we don't study it, it's going to come back to bite us. It is critical that we understand that. So with that, I'll end.